Thank you all very much for coming. This is a book I obviously really liked, and I think I said so in public in a review, because I do think that we talk a lot about innovation in this country, but it sort of becomes a buzzword instead of something that's deeply explored. What John has done in this book is deeply explore what are the conditions that make for innovation. So I want to thank all the people at Intel, especially Justin Ratner, who is the Chief Technology Officer, and Don Baer, our partner in these Intel events, Rush Holt, who is the only member of Congress who is a physicist, or at least gets to officially call himself a physicist. Other people do they do alchemy there, but they probably think it's physics. I think Zoe, if I may, another member of Congress here who we're quite happy to have with us. And
Jared Polis.
oh, yeah, okay. Where are we? Representative Polis, where are you? Oh, there you are. Good to see you, sir. Thank you. By the way, I'll introduce John Lipsky, one of our new policy program directors at the Aspen Institute. Most of you know him from his days saving the world economy, but now he's going to save the world economy at many other places, but also the Aspen Institute running our program. It's your first day here. So with that, I'd love to turn the I'm going to just ask a couple of questions. I hope that gets people started, and then just lean forward and ask questions. But John, you know, when you talk about innovation, everybody thinks, and maybe I contributed to it with a little bit of the Steve Jobs creation myth of the iconic kids in the garage creating something. That's sort of an aberration, and your book explains why.
Yeah, I think at least in Bell Labs they had a kind of specific definition for innovation. It came up. Can everybody hear me okay?
Yeah.
Is that all right? Okay. Really, I think if you go back to sort of how the word was used, interestingly enough, it didn't really make it, didn't really get applied to technology until the late 1950s, I think. That was about the first time I saw it applied at Bell Labs. And what they sort of used it to describe was really the Bell Labs process for what had come out of Bell Labs, things like the transistor, the laser, the implementation of digital communications, and it sort of defined this wholesale process by which an idea was created by sometimes a very small team. It wasn't necessarily a lot of people working together. There was a technology transfer to a development department. Sometimes it took years or even decades. And then there would be a transfer to manufacturing. Innovation described the wholesale process and product of turning really an idea into a thing, a device, a process that had a wide impact and was distributed at a scale.
Mm-hmm. Let me turn to Justin, who's our co-host today, and either make a couple of remarks or maybe open up a question too, if you would, sir.
Okay. Well, I just first I wanted to thank. I wanted to thank both Walter and John for their participation in today's discussion, and I'd also like to thank the representatives, Lofgren, Polis, and Holt. I think we're all here for their attendance. We really appreciate you being here. I think it's great that we've generated this much interest in Washington in the topic of innovation, and I think I'd like to think we're all committed to boosting the amount and perhaps more importantly the pace of innovation here in the United States. Intel's done a number of these things now with Walter and the Aspen Institute over the last several years, and I think that's really served to keep this issue front and center on all of our minds. Let me just say a few things about Intel. We're the world's largest semiconductor manufacturer. We did roughly $54 billion in revenue last year in 2011. I don't think most people realize that well more than half of our business. Half of our revenue is generated outside of the United States, so we're truly a global company. Although, interestingly, almost 2/3 of our organization, we're about 100,000 employees, is located here in the U.S. And over the last 10 years, we've spent about $68 billion on R&D and manufacturing here in the U.S., and we think the U.S. is a great place to practice innovation and to deliver these great products and services throughout the world. So I'm looking forward to today's discussion, and really a pleasure for me to be here today. And I'll turn it back to you, Walter, for the next question.
John, let me open up a line of questioning which fascinated me in your book, which is that when you put people of diverse expertise and backgrounds together, it's where it's most likely to spark the possibility of innovation. And when they're trying to do, for example, the first solid state doing transistors, it's everybody from Bell pole climbers almost, people who've got to string the wires from coast to coast, to solid state physicists, to theorists, and to material scientists. And somehow the notion was to throw them all in the same room and physically they would spark each other.
Yeah, that's right. I think, I mean, it can sound almost obvious today. Okay, you get a bunch of people with complementary talents, you create some tension, you create some synergies or harmonies. But at the time, it was fairly revolutionary, and one of the main characters, I guess sort of the main character of the book, is a guy, Mervyn Kelly, who really came out of nowhere, rose from a pretty poor family in Missouri, to the head of research, and ultimately to be president of Bell Labs. And in the 40s, right after the war, he decided that there were tremendous opportunities in solid-state physics and in developing these technologies, some of which had been used in the war and radar. And so he created this interdisciplinary team. Again, people of all different talents: chemists, metallurgists, electrical engineers, circuitry experts, physicists. He looked for people of different temperaments as well, and different sensibilities. And it's really remarkable how I mean, in retrospect, of course, it was a tremendous success, and within 2 years, this group came up with the tremendous breakthrough of the point contact transistor in 1947. But really, this insight that if you create a kind of environment, an ecosystem, you give people time, a certain degree of autonomy, you pick the best and brightest, you put them together with differing sensibilities, something remarkable is bound to happen.
Do you think that can be done virtually?
If you asked Mervyn Kelly, he would say absolutely not. Proximity was everything. You need people together. You need a kind of serendipity sometimes. You need encounters that sometimes a formalized procedure for innovation doesn't necessarily work. You don't always find what you're looking for when you want to look for it. Sometimes you find it on the hallway or at lunchtime or when you're walking to your car or when you bump into somebody. And I know that other, more contemporary tech companies have taken this up in the design of their buildings. And that was something, too, at Bell Labs, that they were very careful to how they designed for interaction. And they also didn't sequester their physics department, for instance, just in one place. They had people from development as well as research sort of mixed and mingled together. So there were exchanges of ideas that went really all different ways. It wasn't just the basic researchers who passed along ideas to development people and in turn to manufacturing. Although that linear process did happen, there were exchanges from manufacturers to Western Electric, which was part of the Bell system, as well, telling the engineers what they needed and how to improve what they're doing. And if I could just make one quick point with manufacturing, I think, and probably Justin could illuminate this as well, that when you're making something, you're always thinking about how to make it better, and that contact with manufacturing is incredibly vital, both to the research and development process, as it was in Bell Labs, and that it really gave them a tremendous advantage. And it's hard to imagine how you can really do that kind of innovation.
So what you're saying is, if you outsource the manufacturing, you really hurt the R&D.
I think so. I don't think it happens immediately, but I think it happens eventually.
Justin?
Yeah, I'll share an interesting anecdote. When Bob Noyce and Gordon Moore were creating Intel out of Fairchild Semiconductor, they were highly aware of the fact that Fairchild had a very difficult time moving results out of Fairchild Semiconductor Research, which was run by Gordon, and into Fairchild Semiconductor Manufacturing, which was run by Andy Grove. So when they formed Intel, they said, okay, we're not going to have a separate research organization. They coined this term technology development. They threw all the researchers and all the manufacturing people into the same organization. And it had an extremely positive effect, so much so that Andy Grove insisted that the engineers be on the manufacturing floor when the manufacturing people arrived, because engineers sort of had a habit of showing up an hour or 2 hours late. And I think much of Intel's early success in semiconductor manufacturing was due to the fact that literally the process engineers and the and the manufacturing people themselves were co-located and were on the manufacturing floor at the same time.
Which raises one of the points of your book that's not a celebration of Bell Labs. One of the things that they failed at, which is they create the transistor, the point contact transistors. Shockley moves west, and Bell Labs is unable to do what Intel ends up doing, which is, all right, let's make a microchip out of it, and let's really commercialize it. And I'm going to ask both of you, but first of all, why did Bell Labs fail to do what Intel ends up doing, and for that matter, Texas, and Kirby and Texas and others? And maybe Justin could answer as well.
Sure. Bell Labs, I think when you read the book, I very much feel that, it was an imperfect institution. It was remarkable in its achievements, but by no means it had its flaws and its mistakes and its misses as well as its big hits. I think probably the primary reason they missed the microchip is because a lot of the development was vested in one person, a man named Jack Morton, who was very brilliant and didn't believe it was possible. And it wasn't that he didn't believe it was physically possible. He didn't believe that you could get the kind of manufacturability out of putting all these transistors on a chip that eventually Mr. Noyce proved very ably. So he looked for other ways to do that. Perhaps if he had stuck with it as they did out west and in Texas, they would have broken through. But even so, I interviewed some people for the book who in their early days, Morris Tannenbaum, for instance, who did some breakthrough work with silicon transistors, would go visit Noyce at the time, and Noyce would show him a chip and say, hey, look, I put all these transistors on it. And he'd say, oh, wow, that's really neat. But, he didn't say that he had the vision to see where it would go.
But was there something inherent in Bell Labs worrying about being a monopoly, worrying about government regulation, being too big, that it was just not flexible enough to pursue something commercial like the microchip?
I think for Bell Labs, too, yes, there was. And there was also for Bell Labs this issue of government consent decrees where they were permitted to work they could do anything for telecommunications, and they could do anything military related because they had significant contracts with the U.S. military. But was the catalyst there to develop a microchip that would eventually be integral to computing? They were not allowed to be in the computing business. So yes, I think so.
So, Justin, help me with the history here. From what I recall, Shockley leaves Bell Labs, goes to California, starts Shockley Semiconductor, that becomes then Fairchild, which explodes and becomes Gordon Moore, Robert Noyce, and others make it into Intel. How did that process lead to innovation where Bell Labs couldn't do it?
Well, I think let's start with Gordon. He's part of Shockley Semiconductor. I think there was considerable frustration, right? I think they're referred to as the traitorous eight, if I'm not mistaken. There's considerable amount of frustration that that Shockley sort of had the Bell Labs mentality. They just he just moved it to the other coast, and they really envisioned this huge opportunity for solid state electronics, and just didn't think that Shockley had that vision. So that led to the creation of Fairchild. But the significant thing that happens at Fairchild is first the planar silicon transistor. That's the key invention, and then Noyce's brilliant extrapolation from the planar transistor to the planar integrated circuit. And then the problem was, and this is somewhat secondhand. I have talked to Gordon about it at length, but Fairchild Semiconductor management, the East Coast management of Fairchild, I guess Cameron Instruments, didn't share their vision for the integrated circuit, and they got frustrated by their inability to communicate that vision to Fairchild management, and that's what drove the creation of Intel. So I think you have several occasions where people in management positions didn't have that vision of what was possible with that technology, and it was really left to that handful of visionaries in Silicon Valley, as we call it now, to drive that to the microchip industry as it exists today.
Yeah, part of it, the vision, as you say, the vision was not creating computers, but I love the way your book starts, which is early on in the 20th century, them saying, we have to make a phone call from East Coast to West Coast. And that's a simple vision. It's sort of like 1,000 songs in your pocket, whatever your vision of your product is. And does that vision really drive things?
I think so. I mean, there were these, I guess, today IBM calls them grand challenges, but I think in similar ways, there were these big humps to get over. Certainly getting a phone call from New York to San Francisco, thank goodness for the vacuum tube. They could repeat the phone call and push it farther along the line. But yeah, and I think, this larger idea that it wasn't, Bell Labs was very good at setting goals and achieving them, but they were a non-competitive organization in many ways. And I think when Shockley went to the West Coast, he'd really come out of a place where you had vast amounts of time, money, resources to make breakthroughs. But that's very different than especially as we see with the pace of change with Moore's Law and transistors and integrated circuits, about how the iterations come fast and furious. That was not a Bell Labs technique. That was not something Bell Labs was good at. And eventually, when the phone company was broken up and had to compete, they were not good at all.
I'm going to ask both of you a question, which is Bell Labs is set up by the AT&T and, I guess, the Western Electric. And there are a few of those after World War II in which it's sort of industry and science and, to some extent, government. You have Xerox PARC, you have Bell Labs, SRI, Stanford Research Institute, you have, I probably named some of them. And now, Justin, you have your research and development up in Portland, Oregon. Is that a good idea to create these research havens, or is that something we're not doing much anymore and shouldn't be doing much anymore?
You want to go first?
Sure. Okay. Happy to go first. No, and in fact, I think there's this is John's next book, right? Which is sort of the aftermath of Bell Labs, because I think most of us, viewed Bell Labs as certainly the epitome of the second half of industrial research in the second half of the 20th century, right? I mean, that was the crowning achievement, and so there are a lot of organizations were fashioned after the Bell Labs model. I mean, I think IBM Research is remarkably similar to that. Microsoft Research, in fact, in Bill Gates' own words, was fashioned after Bell Labs. In fact, it's often referred to, I don't know if you guys hear it on this side of the country, but it's often referred to as Bill Labs because of its similarity to Bell Labs. And it has many of those same characteristics, I think, that John highlighted. Interdisciplinary teams, all of that good stuff. And the cafeteria was probably the best place at Bell Labs to be, where everybody would sit around having lunch, and you'd get the physicists and the computer scientists all talking and thinking about the future. But I think what is needed now, and what I've been about at Intel during my tenure, is to create a 21st century model of industrial research. I think that's really what's needed. John mentioned the pace of innovation, and that's a huge difference. There really wasn't a Moore's Law sort of driving research, be it academic or industrial research at the time, and so they could take their time working on these fundamental issues. Today, from a competitiveness point of view, you just don't have that luxury. A lot of people want to throw the baby out with the bathwater and say, okay, well, we just don't need research. We'll just keep iterating. evolving, our current technologies and products. We certainly don't believe that's true for Intel. So we've tried to create a research organization that in fact moves with the pace of the industry and the technology, but depends fundamentally on research that I would contend is every bit as good and as much at the level of what Bell Labs was doing. We're just doing it on a 21st century timetable. That's the real change.
Yeah, I may just sort of add that I think I know, for instance, a bit more about IBM and a lot more about Bell Labs than say what Intel's doing. I think a lot of the companies today are thinking of research understandably and appropriately as applied research. And I think what Bell Labs also had was that other component of sort of furthering human knowledge, which is very, very difficult, impossible probably for a company to justify. These are risky science experiments with no guarantee of a payoff. And
sometimes pure theory.
Sometimes, that's right.
Talk about Claude Shannon briefly.
Right. Claude Shannon rode his unicycle up and down the halls while smoking cigarettes and juggling. But really was one of the great theorists of information and sort of how we could express all communications in digital terms and what the best way of doing that was. And which was really just so far ahead of its time in an era when people didn't even really know a lot of people didn't even know what digital communications were, was really assured that the future of the economy really was processing and sending information, and that all information could be expressed in binary terms like that. Mm-hmm. So and wrote a very, very long theoretical paper that is really. But
he's given a haven at Bell Labs that he probably wouldn't have today.
I think that's right, and I think too. The corollary to that is if you just look at the time frames from when Shannon's idea, theory of communications or information theory was developed, or you look at the time
frame.
Which
is what, early 30s?
No, it's a little later. It's probably mid-40s and late 1940s. Or you look at the time frame from when the transistor was created or the laser was created in the 1950s to when those ideas and breakthroughs actually made an impact on culture or economy. I mean, those time frames are enormously long. I mean, we're talking decades. So,
and we're getting sort of the opposite of what Justin said, which is a 21st century time frame, which in some ways doesn't allow the theorists just to ruminate for a decade.
Right. Well, we can we can kind of get into a debate, I guess, over this applied versus basic research. We've spent the last 10 years at Intel Labs creating something called silicon photonics, and not only did we have to create a laser, we had to create a modulator and a detector and waveguides and multiplexers and demultiplexers. I guess if we had done that at Bell Labs, somebody would have gotten a Nobel Prize out of it. But we were doing it in an industrial setting. And by the way, we're going into production the end of next year. So I mean, these things are done on a timetable. I think, and the way we've approached it at Intel is to really look to the university research community for that, for the Claude Shannon kind of contributions. And I don't mean that we've just set that expectation. I mean, we are making enormous investments in funding university research and establishing research centers at universities that are funded by Intel to try to create those environments that existed at Bell Labs in the 30s and 40s and 50s. Mm-hmm. And I think, I actually see that as an opportunity to refresh and renew academic research in this country in a way that I think is fundamental to our competitive success long term.
Congressman Holt, why don't you? You're a plasma physicist, but you also set policy. How does it affect the setting of policy, especially in an age in which the government seems to be decimating research at academic institutions? I mean, in terms of the funding, federal funding.
Well, there's lots to say. I hardly know where to start, but I'll mention that this year the Department of Commerce put out a report on competitiveness and innovation capacity in the United States. This was at a request of some language that I had in the America Competes bill. And they talk about infrastructure. And in John's book, and actually in your review of John's book, you got that key point, which is, well, in the words, to go from discovery to invention to innovation to product or process is more than a single person or a single group can do. The task, this is the quote, the task is too variegated and involved. There are ways to get to proximity without having Bell Labs. I wish, the breakup of AT&T had never happened, or at least it had not led to the demise of Bell Labs. But you can get some of that infrastructure even today, whether it's in incubators where small startups are near each other, even in the same building. It's certainly the case that Bell Labs benefited from their association with Fort Monmouth, the Signal Corps there in New Jersey. Homedale was right next door. So all of these people who were working in the early days of communications were able to collaborate, even though they weren't in the same roof, and even though some of the collaboration was informal. There are various ways to do that, but what you can't get with this pieced together infrastructure is the kind of support that Bell Labs had that went beyond the scientists. I mean, it wasn't just the material scientists and the physicists. I mean, they had the best glassblowers. They had the best circuit designers. The kinds of technicians that are hard to come by nowadays, and that a 2 or 10 or 20 person company can't support. And the incubator collaborative probably won't have. And you won't find the kind. I mean, I visited Bell Labs many times, and I was interested to see. I mean, going back to the 1920s, what they did in amplifiers, negative feedback amplifiers, and high fidelity. Obvious where that's going. Obvious why that's relevant to a communications company. Radio receiver dishes. Obvious why that's relevant to a communications company. But why gravity wave detectors? Why should they be looking at these other things that they had the freedom to look at? Now, it's true, when Tony Tyson and Brown and some others were working on gravity wave detectors, which were never going to be useful for communications, they did make some real improvements in low noise amplifiers. But the point is, they had the freedom to do these rather large scale projects that weren't about getting a phone call from Murray Hill to San Francisco, or from West Street to Murray Hill. So, I mean, to the West Coast. So, how do you get that in the infrastructure today? And that, I think, is a societal question. I think we have to provide that kind of thing in the towns and counties where we want to see the research. I've argued that when a town is building, has a building proposal for an office park on the edge of town, the town planners should not argue just about how wide the parking spaces are before they give the building permit. They should also ask, is there a provision for a wet lab in this building? Should a startup want to locate there? Have we as a town done enough to attract patent attorneys to our town? So building the infrastructure that we have lost from Bell Labs, I think is a real challenge that is society-wide. We don't want to get distracted by just talking about educating the optical scientists, just educating the the communications folks, you've got to find some way to have the diverse infrastructure, including the mathematicians, you know, like Pierce and Shannon and the others. And just one other comment that I think is related to this. I had hoped that 20 years ago, when Don Stokes published his book Pasteur's Quadrant, that we would get beyond this idea, the old Vannevar Bush single line, basic to applied to product. And he was pointing out that Pasteur as an example, but you can choose some Bell Labs cases as examples too. Pasteur had the most applied research. I mean, he was trying to make better wines and better beers, but also the most fundamental research. He set up all of microbiology. We mustn't, again, get trapped in this linear idea that it goes from basic to applied, and therefore the government should do basic and other people do applied. No. We really excelled in those years, in those decades of the 40s, 50s, and 60s when NSF and others sprang up, because we were at the federal level and in the private sector. We were working in all of those areas simultaneously, and too much partitioning breaks down the infrastructure that I'm talking about that we need if we're going to be the kind of innovative country that we want to be.
Secret sauce in John's book about Bell Labs. Let me open it up to further comments or questions.
Well, can I just jump in here I just kind of want to respond to that. I mean, I think what happened in the late part of the 20th century is a lot of corporations began to question the return they were getting from their research organizations. I mean, IBM research is not IBM research of the 70s and 80s. And I think it would have disappeared were it not for the fact that they said, okay, we've got to become much more business relevant. And I think that's really what happened in the late part of the 20th century. There had been any number of these, we want to be the next Bell Labs, or we'd like to be like Bell Labs. And after a while, people began to say, okay, that's great, but what have you done for me lately? In fact, I'm on my way to Detroit tomorrow to talk to a large industrial organization in a popular industry in that part of the country, who's really struggling with this fact. They've had a substantial research organization for, I don't know, decades, 50 years or more, and now they're saying things like, none of the ideas, the technologies that have come from that organization have impacted our products in any way. So I think what is needed, and what I've been trying to do at Intel in the last half dozen years, is define what this new model is that allows you to have a highly innovative research organization, multidisciplinary, incorporates most, if not all, of the Bell Labs thinking, but be highly relevant and impactful on the business. When I took over Intel Labs, Paul Ottolini, our CEO, asked me this question. He says, because we were about, 800 or 900 people at the time, and he says, should you be twice as big or half as big? And I kind of, So we went off and we analyzed that. We came back. We said, no, we're about the right size. I actually have data to back that up. That's not just a simple assertion. But he said, well, okay, how do we know whether you're delivering value to the corporation? And so we created a metric that basically tracked the technologies that made it out of the labs and into the development organization. We did that for a couple of years, and he came back and said, he goes, okay, you guys are doing much better getting this stuff out of the labs. This is the old Gordon Moore, Robert Noyce issue, right? Doing much better. But I don't see you impacting the products, right? So he goes, I'm going to raise the bar. He goes, I'm going to measure you on how many of your technologies actually are on the product roadmap. And, you know, there's no ambiguity that the work you guys have done in the labs has made a difference in our products and our business. And originally, you know, my team was like, whoa, you know, we don't have any control over that. Those are business people, product planners making those decisions. But I said, okay, well, let's just get on with it and see how it goes. And the transformation of that tiny change in the metric has made is remarkable. And you know, I've been out trying to share that with my peers in the industry who I think have lacked the metrics that are necessary if you're really going to improve the contribution, that return on investment that companies make. And if we don't provide a persuasive argument to American industry as to why that investment in research does have higher return, then I think our competitiveness is truly at risk.
Congressman Paulus.
Thanks. Well, hello, there we go. I guess my background as an entrepreneur gives me a different perspective. Entrepreneurs in general are inherently, distrustful of large things, and this whole Bell Labs thing sounds very large. I'll certainly look forward to reading John's book. But I'm actually quite optimistic about the state of innovation today. I think it's a very bottoms-up, grassroots approach. Is there a federal role? I think in the future it looks more like things like ARPA-E and DARPA, SBIR, those kinds of targeted efforts. Removing barriers to startups is critical, and I think this country's come a tremendous way, a long way, in the last 20 years, last 30 years. It's a lot easier to start a company now, both in terms of raising your initial seed capital, a well-established venture capital industry, protection of intellectual property. You mentioned, glass blowing. You can have, that done in China for you and bring it back or wherever you want. You don't need to have the glass blower there. So you can do these things a lot better, I think, from the bottom up. And I would focus on removing additional barriers to startup and innovation. Things like where we have, co-location facilities. They're great, where different startups can work together. You look at what some of the things that you wanted out of that Bell Labs thing. It sounds like they had community. Well, community is great, and we can recreate it in the startup sense too. We have incubators, we have accelerators, we have all these things that really didn't exist, 40 years ago. And frankly, I think they're better because they're real bottom-up type things, and they're more nimble, and they're more likely to be disruptive. But in general, I'm quite optimistic about it, and I would focus from the policy side on removing additional barriers to startup and innovation. And of course, there's a federal role, and I'd like to see it kind of go into this network, and I think that generally programs like DARPA and ARPA-E work really well for that, and we could model additional programs after that as well.
We'll come back to the glass blower issue, but let me get Rob into this.
Okay, well, thanks. As usual, I'm probably more on the pessimistic side. We have this book coming out in the fall, and one of the things we looked in the book at is what's the nature of corporate R&D around the world? And it turns out that we're actually one of the few countries where the shift has gone away from basic research at the corporate level, which was a big surprise to us. So I thought that was kind of a universal trend. Turns out a lot of countries, it's either stable, if you think about the pie between corporate basic, corporate applied, and corporate development. The pie's actually growing for basic for some of our competitor countries, where corporations are actually doing more basic research. And for us, it shrunk. And I think the pretty clear reason why it shrunk is because basic research, or actually I was going to bring up Don Stokes. I really thought that he got it right when he talked about strategic research, which was basic research with a goal, which is sort of off the radar screen in Washington. People can't even conceive of what that is. And if you think about what that is research that has two big fundamental problems for corporations. One is time. You don't get a return on that in the next 5 years, and the other is externalities. So if you were to, I don't know if John, if you tried to do this or not, but I just sort of, as a back of the envelope guess, I would guess that probably 80% of the benefits from Bell Labs didn't go to Bell Labs.
Yeah, might say 90.
Yeah.
Yeah.
So,
10%.
right.
So it was good, yeah.
So in a sort of, if you're kind of a true market, market believer that only market forces should determine what we're doing, Bell Labs was irrational and wasted shareholder money. And they should have way cut back on their research because there was just such huge spillovers. And to me, that's the big public policy problem today, is how do we get companies to act as more collective entities? Bell Labs was really a collective entity. They were producing public and private goods. And I think there's two ways to do that. One is, Justin, you talked about I don't know if you was the word, but you were talking about the Focus Center program. When you talk about these research institutes that Intel invests in, and the key to the Focus Center program, this is one of the most successful programs we have, I think, in government. Nobody knows about it. It's funded by DARPA. It's funded by Intel, IBM. It's at, I think, 6 universities now. It's sort of trying to get Bell Labs through the universities through these public-private investments. But DARPA is considering cutting back on their Focus Center program because it's for DARPA. The DARPA's become like a corporation. They're like, we want returns tomorrow. And the second area, I think, is on tax policy. I mean, we have an R&D tax credit that actually penalizes companies. If you do the R&D in your company, you get a better credit than if you do it at a university. We actually give you a less generous credit if you're doing your research at a university, which is, again, completely opposite with what other countries are doing. Other countries give you a big credit if you do joint research at a university or federal lab. So I think we've got to recognize that there are these challenges and that we can overcome them with some policy changes.
Yes, we've been reading a lot in the newspapers these days about these remarkable cyber attacks and capacities of various states and non-state actors to develop capacity to steal information, get inside networks, corrupt files, what have you. As we see here, innovation has a very strong economic foundation. I mean, someone is working very hard, obviously, to make money. And how worried are those who are in the innovation business, the high-tech innovation business, about the ability of our adversaries to steal information, corrupt our research processes, and this sort of thing? Is that a fundamental threat? I mean, in light of the increasing sophistication of cyber warfare, for example.
We should be asking you.
Yeah, it's a great question.
Help us.
I might just sort of push back a little on the notion that innovation, that the motivating force is profit, because I don't think, I think that's in some ways true in many ways about what goes on in the Valley and New York, and some social media startups and information technology startups now. But I think if you look at really how innovation begins, I don't think that kind of competitive or financial impulse is usually there. And in many ways, all of our current electronic technologies, all of the current economy we use and value today dates back to the 1930s when some physicists were thinking about quantum mechanics, and they, nobody could possibly have envisioned that there was a product in mind. So I just wanted to weigh in on that. And as for the second part of your question, do you have an answer for that? Because it's a great question, but.
Well, we're very concerned about it. Yeah. I think in both. I think in sort of two, in two senses. We know we're under constant attack, and if there's anybody sitting around the table that doesn't believe that you're under constant attack, you're just not paying attention, because we're under constant attack. People are trying to penetrate our systems. And since, most companies have a global network, that means that attack is taking place on a global basis, 24/7. So, we do everything we can within the limits of current technology to protect ourselves. I think the other thing we've done as a company is over the last couple of years decided to make security part of the brand proposition. So that's initiated a tremendous amount of new R&D in our shop to enhance our product families so that they are more defensible. I made a comment somewhat in jest the other day that if the Iranians had our DeepSafe technology, which is an anti-malware technology, zero-day anti-malware technology, Stuxnet never would have hit the centrifuges, because we use it as a test case, and we routinely stop Stuxnet in its tracks, and in fact all mutations of Stuxnet in its tracks. So the potential is there for the technology to at least balance our offensive and our defensive capabilities. I'm not going to say, protect us unilaterally, but I think, for the information and communication industries, security has to be job one, and I don't think we're quite there yet. And even within the critical infrastructure sectors, I don't think there is that complete acknowledgement. I think people have kind of come to see it as cost of doing business, that there are going to be certain financial losses, there are going to be certain intellectual property losses, and that's just the way the game has played. And that's unfortunate, because I think a lot could be done if we had better support out of the critical infrastructure sectors for aggressive efforts on the security side.
Congresswoman Lofgren, yeah.
Yeah, this is something I think about a lot, and certainly we rely on in the Congress on Jared, who was an entrepreneur, and my friend Rush, who was a scientist. But I just come from Silicon Valley and observe what's going on there, and I observe also that we have pretty much failed to create another Silicon Valley anyplace else in the world. And why is that? And I really think I'm an optimist, but I also see some signs for concern. We've got lots of great science going on in the country. We need to make sure that we continue to fund that in a free-flowing way. But why does it work in Silicon Valley? We have an infrastructure that exists that no one designed, but it builds on itself. I really think that it was Frederick Terman and the School of Engineering that made it possible. When you think about Xerox PARC was similar to Bell Labs. I mean, they did all kinds of cool stuff, but they never developed anything. And John Warnicki and Chuck Geschke had to leave in order to do Adobe. They were both there thinking up the ideas. So really what's happened is Stanford, unlike Harvard and MIT and some others, really nurtures a connection with industry in a way that's very different than other universities. And I don't know, Terman started it and it's continued, where you see the professors are actually starting companies, sitting on boards, and that is something that is celebrated in the university and in industry. And I really think that is key in translating science and technology into commercial ventures. And how can that be replicated? Here's the concern I have, that we can't take our foot off the accelerator when it comes to funding science, and also have very grave concerns over the state of the national labs right now, not only in terms of funding, but there was a National Academy of Science report that just came out in February suggesting that the NNSA is now micromanaging the science at the labs to the detriment of science. So you have to have some capacity for the scientists not to be told how to be scientists if you're going to have the kind of innovation that we're going to foster. And I think it's sort of a virtuous, I don't know if it's a straight line, but it's a mob scene from science to somebody who wants to create a company that may be with the scientists, to the venture capitalists, to the infrastructure. And I really think it comes with celebrating commercialization in the science and academic community is the key to it, and what's missing in most of the rest of the country.
Yeah, no, it's absolutely true that Silicon Valley and the connection to Terman and the engineering school of Stanford in the 30s and 40s and the creation of that park is sort of a next book-like thing for John to do, and the question of whether other universities can replicate that here or around the world is particularly interesting. Chuck, were you? Yeah.
Yeah, I think the issue.
Why don't you punch your button if you would?
cybersecurity is a heck of an opportunity, is what it is. But I think to follow up with your comment about Silicon Valley, what's really, and touching on what you said, is a culture of openness that's critical for innovation. And I would say people have written about the idea, if you find a community that's openly acceptable homosexual communities, you're finding a community of tolerance and openness. Early adopters are not judgmental. Early adopters are open. And I think there's a direct correlation to what people would complain about the ridiculous discussions in San Francisco of it's okay to be nude, but the whole argument whether if you're nude in public you have to put something on the bench before you sit down. That's a correlation to really an openness to innovation. But I'm serious.
Trust Bucky to get us right to the point there. Yeah.
But it's not only the innovators, the entrepreneurs themselves, it's the openness of funders. A community of openness to early adoption, to non-judgmental approach to things that is critical. And that's why I bring back this community attitude. It's one of the problems the South has.
Yeah.
A rigidity. In Silicon Valley, in San Francisco, you don't find that rigidity.
Thank you, Bucky. Amy, and I'm trying to keep track of people who've caught my eye, so catch my eye if you want to. I have Michael too. Yeah.
Yeah, Amy, and I spent 7 years at Stanford, so I love this open collaboration. I'm now at Harvard writing a book on high-impact entrepreneurs. So my question is for John, and it's at the individual level. I'm curious who the next Gordon Moore is, and if these people are reincarnating, or if the dynamic of the team and the individuals, if you see it today at Facebook or Dropbox or Gogglebot, or what's on the next horizon?
The next Gordon Moore is Elon Musk. Elon Musk. Maybe. I don't know. It's a good question. This is really fascinating to listen to. I think there can be simultaneous truths. I go to Silicon Valley a fair amount. In fact, I interviewed Elon at Tesla a couple of months ago. And it's amazing what goes on there. And I really, the openness, the constant agitation of ideas that kind of, create this unbelievable machine of startups. But I don't know if it really addresses the question of whether there's the well of new scientific ideas or new breakthroughs that you can't really see, that you may need to draw upon many decades hence. And I'm not sure if this is answering your question exactly, but I think we can have different kinds of heroes, the people like Steve Jobs or Musk or Gordon Moore, but also the Claude Shannons and the sort of people who really create these breakthroughs. And I think they're both necessary.
Let me real quickly turn that question to the fact that for the past 30 years the breakthroughs have been in information technology, which allow a certain type of innovation and even a garage entrepreneurship. If the next wave of innovation is going to come in more wet stuff like life sciences, genetics, or whatever, will that require a different type of industrial organization for innovation?
I think so, and energy too. I think as the VCs in the Valley have found, it's been very hard to kind of commercialize some of these ideas in that same time frame that they were using for information technologies and software, which you could roll out very quickly and incredibly profitably with a relatively small investment to start and get just phenomenal returns. But energy, life sciences, yes, and I don't know if that person has emerged yet, but I think, Walter.
I mean, the next Gordon Moore may be somebody in the life sciences,
Yep.
We already see some of the people at the Broad Institute or whatever. I'll get with Michael. I think you were next. Yeah.
This is an excellent contribution. Thank you very much, Walter. Walter, you wrote a book on Steve Jobs, which reminds us of, I think, the highest valued company in the world right now, Apple. Justin, you mentioned that Bob and Gordon put together manufacturing and R&D, and yet Apple, I think, has largely outsourced manufacturing. It's a very different model. Maybe they're a media company and not a manufacturing company. But can our panelists comment on a company like Apple that divides its R&D and its basic IP with outsourcing and manufacturing, and what that means long-term for a company like that.
You want me to go first? Well, I do a lot of work with Apple. Let me preface everything I'm going to say with that. And they're a most unique company. You know, I tell people working with them is not like working with anybody else. So, you know, I think as a as a company that is primarily focused on creating these extremely compelling user experiences, you know, they are focused at a much higher level, at, you know, the technology, right, at the experience level. So for them, it's not about the high resolution display or you know, the incredibly thin packaging or those sorts of things. It's in creating that experience, and they will go wherever they need to go to get the ingredient technologies. And I think that's why their manufacturing looks the way it does. Now, that said, I think the way they manage their supply chain is perhaps the biggest innovation at Apple. You know, nobody, you know, runs the supply chain the way they do, and so they're able to get all of those upstream suppliers to do exactly what they need, and to do it many ways to the exclusion of their competition. Mm-hmm. So, no, they're not direct manufacturers, but their supply chain model is highly innovative, and I think is really what's propelled them to the forefront.
The question you ask really worried Steve Jobs throughout his life until the very end. And when he first started Apple, both the Apple II and especially the original Mac, he created his own factory in Fremont, real nearby, so that the people designing it and the people with the materials had to be there with the manufacturing floor and go see it and work together with it. And even after he's ousted, because that's not the most efficient way to do things, and in '85 Apple was having some problems, when he creates Next Computer, he does the same thing. He puts a manufacturing plant right next to the headquarters because he believes that your research and development cannot be separated from the person on there trying to figure out what type of glass do I need to put on the device. Clearly, that doesn't work either, and when he comes back for his third act, which is in '97 when he comes back to, it was brought back to Apple, he finally starts doing what pains him deeply, which is outsourcing the manufacturing. And he feels, and it gets back to your glassblower almost, Congressman Polis, he feels that you're losing something there. And when he does the original iPhone, for example, he wants the world's greatest glass. He does not want a plastic face on it. And so nobody can make the glass the way he wants. And they've outsourced to China the making of the thing. And the Chinese autoclaves are making glass that was good enough for the Apple stores. He looks at it on the iPhone when they're trying to do it, and he had a technical phrase for it, which was, it sucks. So he just goes ballistic, and he won't do it. Finally, somebody says, call Corning. Maybe they can do it. So, being Steve, he picks up the phone, calls a switchboard at Corning in New York, and says, let me speak to Wendell Weeks, the CEO. And they say, well, we'll take your, and he slams down the phone and says, typical East Coast bullshit. So he tells a story to John Seeley Brown, who's on the Corning board, who gets Wendell to, Wendell, not being an idiot, calls the Cupertino switchboard and says, let me speak to Steve Jobs. And they say, fine, fax your request in writing. And finally, Seeley Brown gets them together. And Steve says, I want this type of glass. And Weeks says, well, we did, you know, this Gorilla Glass process with an ion transfer. We could. He said, okay, I want it by September, this much. And he said, well, we've never manufactured it before. And Steve said, don't be afraid. You can do it. And Weeks calls his plant right next to Lexington, Kentucky, and says, start making Gorilla Glass. And that's why every piece of glass on your iPhone or iPad there is made by Corning, and he then moves his design team, including Johnny Ive, to actually blow glass, to get to your very point. At Corning, They move there because they want to be with the glass blowers to make sure it feels good. Now, that's Steve at his most obsessive. But he said to me, and he told me this story, and he said, that's why we're getting screwed up in this country, because I can't get enough engineers to put the manufacturing in America anymore. I need 30,000 engineers, just industrial engineers, not MIT, Stanford engineers, to support the 700,000 jobs at Foxconn. But our education system is so screwed up, I can't do it. So I'm sending all those jobs out to Foxconn. Once I've done that, Johnny Ive is starting to spend a lot of time over there in Taiwan and in China, because the designers have to be next to the manufacturers. And he says, my R&D people are now I'm going to outsource the R&D because they have to be next to the manufacturing. He said, that's why it's important to have manufacturing in this country, because in the end, my R&D people and my design people have to be there on the factory floor. Steve may or may not be right, but he was in quite despair about manufacturing being done elsewhere, despite what you said correctly about, I mean, as part of his supply chain, you've watched him try to switch to the Intel chip, but he knows, and he's probably sat there with the ARM chip, the ARM, your competitor, and sort of showed you the cycles and how you have to do it for him. But I think that if he could have had one thing he could have done, he would have said, America's got to bring manufacturing back here, otherwise we'll start outsourcing R&D and design. Sorry, Alan, I've been... And then Baring.
So, John, I had one question, was that how do you define innovation, right? So when we talk about the iPhone, is each individual app an additional level of innovation? Is only the original iPhone innovation? Is each marginal new model innovation? How do you structure innovation in your mind?
I think we use the term pretty loosely now. I don't want to be dogmatic and say innovation has to be this kind of thing. It might be nice if we used it as a kind of high bar, but I mean, I certainly consider the iPhone a great innovation. I think it's it's a different kind of innovation than, say, some of the things that were happening at Bell Labs when we talk about transistors, or later still at Intel or Fairchild with integrated circuits. But I do think the old Bell Labs definition is a useful one, that making something that is better and cheaper than exists already, and that was Mervyn Kelly's sort of shorthand definition, better or cheaper or both, and something that in turn isn't just an idea or a new app, but something that defines a sort of lengthy process from which something goes from being not just an invention and not just a developed invention, but something that has a broad impact.
Banning?
Two quick questions, even if I only was at Stanford for 4 years and not 7, but I still have a couple questions. One is on 3D printing additive manufacturing, which has all kinds of implications, but one of which, relative to this, is bringing the developer right to the manufacturer, the same person. It seems to help, perhaps, not only in prototyping, but in actual, ultimately, manufacturing of goods, to really change the paradigm of how, and help this process of bringing all the developer, the scientist, the technologist, the manufacturer all together in one place. And I wonder what you think about that. The second question is, and Steve Johnson, I guess, in his Where Do Good Ideas Come From, stresses the fourth quadrant, that it's the open. It's the government working with scientists and universities, and it's not the individual corporation is not as innovative over a long period of time, because it's it's protecting its IPR, it's closed, and to make the innovation to compete with the other companies. This conversation is kind of fudged across both, because there's so much emphasis Intel funding research centers and universities. But how does that play out? Is there an actual tension and problem there, or maybe not? Because it hasn't been directly addressed, but I think it's really important to look at that fourth quadrant versus the third quadrant.
Well, I was going to start with manufacturing. So, all right. I'm really glad you asked that question, because I think whatever you want to call it, direct digital manufacturing is a game changer. I've got actually a big internal study that reports out next week on it, and we've actually in that effort, we looked at the desktop publishing revolution and how that, how that moved forward. And in fact, I thought it was interesting. We talked about, the folks coming out of Park and doing Adobe. Adobe type was a critical element, certainly, and the laser printer shouldn't go unmentioned here, and Ethernet and a few other things. But all of those led to, the revolution in desktop publishing, which, roughly a decade later made it possible to publish on the internet. And of course then, and you all know, no place better to know than here in Washington, how that disrupted journalism and, and sort of changed the way we think about media and communications in general. So the question I posed to that team was, okay, you see a lot of the same things going on here. Are we about to experience this revolution in desktop manufacturing or direct digital manufacturing, whichever you prefer, and what does that mean, and what's the significance of that? And perhaps most importantly, will it usher in a new era of individual innovation, much the way desktop publishing did? So I think the question is very timely, and we're probably not quite there yet, but I would say we're certainly within the balance of the decade. It'll either be this huge success or this giant disaster, but I'm hoping for the best in this case.
I'll make a point on open versus closed and what Steve writes about in his book. I think there's always a tension, and you need both models. If you look at John's great book here, you see that the invention of the transistor and everything else becomes pretty much of an open thing, because Bell Labs feels it has to license it around to anybody who wants to develop it. The other extreme is Apple, which has a very closed system, and pretty much if you want, iTunes, you have to have, your iPod hardware, iTunes software, iTunes store. It's very much a closed system, and you get innovation, in my opinion, in both, but you want that tension. If you look even from Xerox PARC, out of Xerox PARC comes the original Macintosh operating system, which is a closed system that Apple controls totally end-to-end hardware and software. But then comes Windows, which Bill Gates licenses out so that many different hardware manufacturers can do it, and you have an open thing. You have this replicated with the Apple iOS now and Google's Android, open versus closed. I don't think there's a right answer, and there hasn't been for the past 1,000 years between open and closed, proprietary or not. But the tension between the two allows, innovation to come by protecting intellectual property, and then innovation to come by opening it up so that you can have a crowdsourced almost innovation. That's my opinion. John?
Yeah, I also, to make a point about Bell Labs and just add on what Walter said, if we look at just the exchange of ideas, I think sometimes Bell Labs has been seen as a kind of closed organization, but what you really find if you look at the historical record is that there were all sorts of exchanges with Bell Labs. Scientists were discussing things with the academy. There were all sorts of speakers coming in and out. There were military contracts, so there were all sorts of exchanges in that part as well. But I very much agree. There's no one way to innovate. I have a kind of knee-jerk distrust when someone says, open innovation is the only future. I don't think, I think we can look at Apple and say, well, that's not true at all. Different things work for different companies. When there are IP issues, open innovation doesn't work at all. And I often look at sort of what happened with Boeing's Dreamliner, for instance, with kind of trying to assemble all those parts by farming them out to different companies and with a lot of delays and problems and the like.
John, will you ask me?
Well, I will. I feel a bit reticent. I haven't read the book. I will. The obvious question, you thought of the Bell system as archaic, and you thought of the goal of the management of the Bell system is to slow innovation and to be able to derive as much profit for as long as possible out of their installed capacity. So you thought of the firm as inhibiting innovation, and that leads to the notion of the Bell Labs as a kind of a facade that allowed them to say, oh, we're very advanced. It's just, just our systems aren't, your telephone system's not advanced. So I'm wondering if, how we should, if that's an incorrect vision, I don't think it is, but if that's the case, how do we, what is the message of Bell Labs? Parenthetically, for an economist, we all remember this glory days of the Bell Journal of Economics.
Yeah.
That was wonderful for academic economists, but I don't think it advanced the welfare of the world very much.
Yeah, that's a great question. Well, I think you can think of the institution of AT&T as being different than Bell Labs too. I mean, I think Time Magazine had a famous quip that no company is more conservative, but none are more creative. I think what Bell Labs was doing was, in fact, creating too many ideas, too many innovations to actually ever be used by the company that was funding it. And so, I mean, what was it not innovative? Well, Bell Labs certainly was. I mean, it was a kind of gushing river of innovations that just could not get out through the organization of AT&T, through the structure that existed because of their consent decrees and their agreements with various states and regulating agencies. But again, they were building things to last 30 or 40 years because that was the idea. They were not building things in a kind of competitive environment that were going to last 2 or 3 years. So it was that contradiction that, the monopoly was arguably not good for consumers. It can slow the rate of innovation, but at the same time, Bell Labs was very good for the country, at least long term.
So if I could, so is it a paradigm or was it quite wasteful?
Was AT&T quite wasteful?
Know that.
Oh.
Was Bell Labs?
Well, I don't know. I mean, was it quite wasteful? It
Resources.
wasn't a lean organization by any stretch of the imagination. If there were people of expertise who were not being tapped at all hours of the day, or there were extra people working there and yet only had one idea in 10 years, but it turned out to be an idea that was worth billions or trillions, I don't know. I've never seen it quantified. I've never actually even seen the value of the transistor quantified. I don't know how you put a value on the laser. So,
Well, this actually brings me back to my early comment about 20th century industrial research. I think a key tool is venturing, and I think it speaks to this comment earlier about about startups. I mean, Intel Capital is the largest venture capital organization in the world, right? Why didn't Bell Labs have a venture capital arm? Because I think they could have avoided these consent decrees and whatnot if they had just said, okay, the AT&T system is not going to absorb this technology, but there's certainly a world market for it. So, we'll fund it, we'll bring in other venture capitalists. I mean, this is the ICAP playbook, and we'll start new businesses. This thing about we can't be in the computer business, if you've ever seen an ESS number 5 switch, that's a computer, and then some. Just anecdotally, I was in a computer history museum board meeting, and we were debating whether the ESS 5 was a computer or not. Yeah. So as to whether, we were trying to decide whether it qualified to be in the computer history museum or not. You'd be surprised how many people said, oh no, that's not a computer, that's a piece of networking equipment, doesn't belong in the museum. Totally bizarre. But I think that, that idea of venturing is absolutely critical in this 21st century industrial research model. I did want to speak to this question of scale, while I think startups are one of the most wonderful tools for innovation we have. There are classes of problems that require scale and are really beyond the resources of venture capital, not so much in a financial sense, but the ability to assemble the critical intellectual resources to sort of pull it off. And maybe John can comment. I think large industrial research organizations account for actually the majority of the innovation in this country, if not globally. The last comment I want to make is about openness, particularly between industry and universities. And I think if you're going to use the universities in the role that Bell Labs played throughout much of the 20th century, you've got to come at it with an open model. The 6 and soon 7 Intel Science and Technology Centers we've opened over the last 18 months all operate under an open collaborative research model. We view the research as pre-competitive, and it's the only way we're able to get the best academic people to work on problems of interest to us. If you tell them, okay, here are the IP terms, page after page about, patents and all that kind of stuff and disclosures, they run as far and as fast as they can. But if you say it's open, you're free to publish, we view it as pre-competitive, the burden is on us to take those learnings and translate them into innovative products and services. You get absolutely the best people, and they naturally form communities of researchers and attack those problems. And so that notion of open industry university research, again, I think a key tool in this 21st century model of industrial research.
I hope our Congress people are listening to that as I worry about the funding. Last comment or question, Blair, and then I'll let John wrap it up.
I guess to go back to Walter's earlier question, can the virtual ever replace the physical? Because I was struck in the book by, really, Bell Labs didn't have a choice. The only way to have that kind of collaboration was to pull people into a building together, to put them in a cafeteria. We've lost a big input, which is monopoly profits, but we've gained huge inputs, which are the ability to share data, big data, across the continents, the ability to collaborate in real time. And I guess, there are a number of different models that are emerging. One thing's of CERN, where a number of people collaborate. It's not quite the same as Bell Labs, right? But one thing's of that. I can't remember the exact circumstance now, where some problem that hadn't been solved for 50 years was put out as kind of a wiki, and within 3 weeks, a number of people together solved it. And I just wonder, as we, in the same way that as we transition from, say, vaudeville to radio to broadcast television, the narrative stayed, but the means changed. We now have a completely different means of collaboration. And so I guess my question for you is, from that, taking completely different inputs of communications, big data, how do we structure that kind of collaboration to lead to innovation from the lessons you wrote writing that book?
Do you mean how do we structure it between companies, universities?
I would say for the good of humanity. How do you structure that collaborative / innovative process?
I mean, it's a fantastic question. Yeah, boy, where to start? I think that maybe I can. Maybe I'm just not sure I quite understand how to answer that. How do you structure how to use big data? Is that correct? How do we?
Well, I guess given that the way we collaborate today
Right.
is so completely different. I'm spending a lot of time with universities. I mean, every university professor, works on these fantastic networks, goes home and works on really lousy ones, actually.
How do we make sure this distributed model we now
Right.
have?
That's a better way of saying it.
Is functioning. I see. I'm sorry. Gosh, I'm just a writer. I get into these policy holes. I don't know. I think sometimes I've been asked over the last couple of months. Are we innovating enough? Are we doing it the right way? Are we creating the innovations which may well be in big data or quantum computing or life sciences that we're going to need in 10 or 20 years? And I sometimes say, I don't know the answer, but I feel like we haven't necessarily been asking those questions. I mean, maybe they're asking them more in Washington. They don't ask them too much in New York for some reason. But I feel like that's a good place to start. I don't know. I mean, nobody today brought up the sort of gathering storm reports, which I found very interesting and alarming and useful, too, in looking ahead. I'm not sure that answers the question about big data. But I just hope we keep asking these kinds of questions and really start thinking long term and the payoff of some of these things to society. Because I mean, the one overriding lesson of Bell Labs, at least for me, is not, and this book too, is not how do we create another Bell Labs, but that these investments in R&D and really thinking long term can pay off in ways that are really unimaginable at the time. And it can take 10 or 20 years. It requires a tolerance of failure. Which I think is something that didn't come up today, but is probably something worth thinking about as well, that innovation and failure are very similar animals, and they live in the same cages. And that too, that those are two, I think, timeless lessons of the book and the Bell Labs too.
Well, thank you very much. This will continue. We still have more questions, but let's continue it informally over coffee and whatever. And I found the book absolutely. Is the book out there for sale, or get? Okay, you should get the book. It's awesomely good.
There's a bookstore around the corner.
And I really want to thank John for being provocative, thoughtful, and also Justin and the Intel Corporation for this. Thank you all very much.
Thank you both.